Right. Trying something a little different today. Seeing if I can get the stream here working with OBS, and it looks like OBS is doing what I want. So let's transition over to the course stuff. I'll move this out of the way for now. Yeah, transitioned over there, good. All right, it's looking like things are doing what I want. So, what are we doing right now, guys? I'm working out of a hotel in Dayton, Ohio, which is not my favorite place. Didn't expect to be in Dayton, Ohio, maybe ever in my life, but this is where we're at. So, if you guys can hear me over on Twitch or YouTube and want to let me know, I appreciate it. But I think you guys should be able to hear me okay. I don't have my normal microphone. I'm just using the laptop one, so that's not going to be as good. But we'll just hang out a little bit and do some Linux stuff. And we'll talk through the last 5x5. Nice. Thanks, Shock Value. We're just, we're not working too hard. I've been out here in a data center. And the data center I've got 3 supercomputers that are going in out there. And now 2 of them are less super. So it's weird. We call them supercomputers, but they're high performance compute systems, right? And 2 of them are less like super. They're kind of only like about 3 rack systems, but they're still, they'd blow anything away that any of us have in our home labs. They're still, $1 million systems for what they are. But then the big rack is, the big one is about 29 racks. And that's a big old beefy boy with a whole bunch of GPUs and a whole bunch of other stuff in it. And I've been out here, I had to replace a switch today. I had to do a bunch of extra fixing of some devices that were busted, just physical hardware stuff. Which is funny because I'm a Linux guy and they don't really normally make me do stuff like that, but it's just the project I'm on. And I'm one of these guys, like I'm a team player, I'll do whatever they need to get everything working, so. All right, so we're talking about, this is one of we were doing this course the last few weeks, and we can do that, or we can just play right in the Linux world if we want. We can go right in here. I'll leave that up to you guys. All right, hold on, let me turn the music down a little bit. I got it at 10, which is a little loud. How's that? Better? Normally I got my mic right in my face. So normally it's a little louder. But I would just go right into Linux if we want. You're doing some Docker, nice. Shock Value. That's it's definitely useful. I think it's the way most workloads in the industry are going. I don't think there's anywhere where you won't find value in Docker, so that's good. I don't think there's any place out there where it's not like, oh yeah, hey, we've never, even tried to do something in Docker. Even a lot of high-performance compute workloads that I work in, they bring in Kubernetes to try to figure out where the value is, or where they can do some of the things that they do a little more efficiently. Let's move this over. What do we got here? Let's see. Let me tell you guys some stuff that's going on. We've got our Discord. Fix this thing to be the right size because for some reason this other monitor is just messy. What I want to show you guys is we've got a discussion coming up on Saturday with M-Pesa. He's going to come and talk to you guys about Kubernetes in the enterprise. He's been doing that with a startup, and then now he's a software engineer working primarily on Kubernetes. And he does it in his home lab. He came and talked to you guys last month about Ansible, and people really liked his talk. So those talks are always free. This one will be on Saturday, January 11th. But if you want to see what the time is, you got to look at it in your whatever your time zone is, right? I can't tell you. Yeah, Trevor, I don't have my my good microphone. I don't have my my Blue Yeti with me here. I'm just talking. I'm basically just yelling into my laptop right now. So hopefully you guys can kind of hear me. But I will try to speak up. Yeah, Docker and K8s go hand in hand. It is good to learn the Docker stuff first, I think, for sure. In fact, let's see. Unless you guys tell me otherwise, I'll just start the Linux systems administration stuff. We're just reviewing. I was doing kind of this review the last few days of the course that we did in Discord for free. Anybody can go in there and play with it. It's coming to an end on the 19th, though. And what I mean by it coming to an end, like you can't complete it after the 19th. You can still do it. I mean, it'll still be valuable to you to learn stuff. You just can't get the little certificate that'll be there. So, anyways, all right. So last week, in this for week 13, capacity planning, management, capacity planning, architects, and then storage system testing. So I don't remember exactly what the context was, but this week we had something around security, team discrepancy, and prod servers, and then building a new hardened image. So those were the things that I made the people do on Unit 13. Then they took some notes, did a lab, worked on the project. So let's go talk about what this is. So we were doing server hardening this week. So building out golden images and how an initial deployment and then pipeline automation can make this much more effective. You know, when we go to make something a production ready system, as opposed to just, I mean, we can do whatever we want in our home labs, right? We just build shit and do whatever, but we can get in and make things production ready for a company by just doing a few extra steps, right? And then making things into like pipeline and automation. Let me show you guys one, like in my home lab here. And this one, like I'm always like halfway done with stuff, but let's go to root, Ansible, and then my playbooks. And in here we've got like, yeah, let's go to like my HPC deploy. So I was building this out for the home lab, and we had like a lab environment.yaml, which is a definition of all the nodes. So C node 1, 2, 3, 4, C, and then the C login nodes and C slurm. Yeah, so I had this smaller little set of nodes that we were kind of building in my environment. And then they pulled from a template, right? And this template is defined. Oh, it's actually funny. I can't pull up my XCPNG right now to show you guys this, but because I'm away. Maybe I could open a reverse. I could probably punch a hole and get it, but it's not that big of a deal. But the point is, this is a template, and they were all using the same template to deploy these nodes. And then you say, okay, well that's all well and good, but what's doing the work with this? This is just a definition. This is some YAML definition of some things, right? Nodes, and then node. That's how I defined these. Well, the way that this deploys then is with the lab deployer, and this works. There's some bugs to it, but it works. And all it does is from the local host, go open the vault. The vault has the username and the password, and then run through the item node list for each host. So each host, as it connects through, it's going to run through the Zen server guest once. This is the module. You can go read about what the module does, but basically it just goes and pulls the templates out of test VMs and builds one as it loops over all the nodes, and the nodes are defined from that file lab environment that we just looked at. So it's going to loop over C node 1. So see how it says node and then name and then value. So node.name is item.node.host. Yeah, item.node.name is down here, right? Host is where we're putting it. So I had this set up so we could put it on different devices in our system if we wanted to. But then the template would have to be there, right? But the point is, you could spend a little time and you could automate how these deployments happen. And I've proven these and I've shown these before, how these deploy out to the home lab. But then change management. We talked about, if we're going to build these systems and harden them, then we need to have a way to make sure that people aren't just unhardening them in the environment, right? And what I mean by unhardening is the idea that the people are just coming along, and because every ticket is easiest to just make everything 755, and every ticket is easiest to just put a web server when somebody asks for it, that's different than following a change management process and saying, well, why the hell does a database server need, like, why should a database server get change management? Or change management. Why would a database server get a web server on it? It doesn't make any sense. Really, really bad practice as engineers, right? So we're not going to do that. So, all right. So let's talk about this a little bit. And we talked about we harden systems to a security standard. That security standard can be one that our company writes itself. It could be one that we get from somewhere out in the world. I'm constantly telling you guys about these security standards that you don't have to memorize, but you might have to work with, right? You have to know how to reference things, right? So we can use our own standard. We can find one that aligns with our security posture of our organization. That's a technical term, security posture. You really need to understand what it is if you're going to build things for your organization. Because if you build things that are not acceptable to the company's security posture and what they call acceptable risk with like a risk management framework, you're either going to have to rebuild it again, or if you're going to not rebuild it again, you're probably going to have to go find yourself a new job, because the company has a standard and you have to build things that adhere to that standard, or they'll try to find somebody that does. And that may be difficult to do, but the point is you can't just keep not adhering to a standard. That's pretty much the opposite of engineering, right? We can, by the way, we can get ahead of this stuff, and we could offer to write the standards that we like, right? Like, hey, I like CIS benchmarks and they worked really well somewhere else. Okay, well, let's use those. Doesn't matter, right? But I tell you guys, a lot of times, a lot of this is just about getting ahead of these problems before they come up. So, all right. So there's this dichotomy in security. I've talked about this before. Perfect accessibility versus perfect security. And I made these against the concept of confidentiality, integrity, and availability, right? Perfect accessibility, anybody can view it. The truth will set you free, right? Anybody can see it, it's true. Perfect accessibility, anybody can change the material that you have. They can change it and it'll always be, accurate or whatever, hopefully. But if anybody can change it, you guys have all seen, that's, the internet has proven that Bodie McBoatface will win over anything else. And if you don't know what that reference is, you should go look it up, because it's true. The internet will, if anybody can change something, it will be in a bad state when you come back to it. That's a fact. We just had something in our Discord. I had left a webhook open. I always tell you guys, the webhooks are open until somebody abuses them, and somebody went and probably scraped the page and found it, and then they just started putting stuff into our sandbox channel the other day. So I deleted it, got rid of the webhook, and did all that stuff. But the point is, anybody can change things that can cause problems. And then the last one is anyone can use all the resources. Well, if a person can use all the resources, then they will. Your users will use all the resources if you don't protect them from themselves. Then down with the shortness, yeah, that webhook can sit. I honestly didn't even see what it was, but it didn't look good, whatever it was. It was like, there was political stuff, guys. There was like stuff. It was weird. It was real weird. So what are we doing tonight? We're not working too hard, guys. I just got done teaching a college class. I'm on the East Coast, so it's 10 o'clock for me right now. But tomorrow, the contractors don't actually have to be in the office, but some of them said they're going to for this deployment. So I'm going to be in there working in the office and data center out here in Ohio, where I'm working out of. So, but yeah, look over here. On one side, perfect accessibility, and the other side, perfect security. We protect the view. You can only get in if we authorize. We have to verify that you are who you say you are, right? So you have to come with your different methods of how you prove you are who you say you are, right? We call that authentication. That's the process of proving, yes, this person is who they say they are. That's authentication. We do multi-factor authentication, which just means we have more than one way to know. So there's factors of authentication. One is something you have. So like a PKI or a certificate or something, right? Like a CAC card, CAC, right? And then those types of things, and then you got passwords and pins. Those are things that you know. You have biometrics, which are things that you are, and you could even have places you are or VPNs that you're connected to. And there's all kinds of ways to authenticate with multi-factor authentication, where we use something across each of those different facets there to figure out, or factors as they are, to figure out what something is. So, okay, or who somebody is. But then once we prove you are who you say you are, then we give you access only to certain things to view, only to certain things to change. And we only give you protected availability, meaning we lock you in your own little jail so you don't use all the resources of the organization or the tool. So we jail the users or whatever. Do any of you know, like your phones, all of you have phones probably of some type? Did you guys know that your phones are completely jailed? None of your processes, unless you give them explicit abilities to, can talk to other processes. That's because of the jailing within your phones. They jail every process. So everything that comes up on your phone can only take up so many resources. They can never be over the control of your device where a phone call can't come in. You guys know that? That's how your phones are designed nowadays. Yeah. Hence jailbreak. That's exactly what the term jailbreaking means, is getting out of the jail of resources. But guess what happens if you jailbreak your phone and any resource you have can use any resource? If you call them because something's going wrong, they're going to be like, look, we can't help you. Like, how can I help you when you're just going to do whatever ratchet stuff you want to, right? All right. So just think about that. So how do we harden, right? There's standards. There's the Secure Technical Implementation Guidelines, the STIGs. There's the CIS, Center for Internet Security Benchmarks. Those are free, but you do have to download. You have to give them your email, which I consider not completely free. But CIS benchmarks are really easy to get your hands on. And then STIGs, the Secure Technical Implementation Guidelines, they're constantly updating those for how you should, the posture you should have for your servers. And then you get a score. And I've shown you guys before, but there's these tools that are out there for free that you can run, and the STIG benchmark tools and stuff. Then down here, there's like SCC tool for scanning. There's the OpenSCAP workbench, and these are ways that you can see where you're at, and you can even write. They will deploy Ansible or Bash code for you to fix things within a system if you want them to. Okay, I actually need to do the OpenSCAP. I need to do a lab on that for you guys, so we'll get to that. But anyways, this is how we harden systems, right? This is the standards we apply, the tools that we might use, or you might just do good best practice type things on them, right? I mean, but typically it's good to start from somewhere and figure out like what you are or aren't going to take, right? If you are not working for a government agency, or you are not working in like financial, and you don't use either of these, you just happen to use them because they're free, and you're like, I'm going to use some of these and I'm not going to use others, that's fine. Still better than not securing anything, right? And then here's hardening best practices. This comes from that little document that I had put together before for you guys. I think some of you guys have seen it before, but it's like, where's it at here? Hold on. I reset my machine the other day. Oh, is that what's going to happen here? Oh, hold on. Move this over here. Where'd this go? This is legitimately one of the weirdest things. Hold on. Where's this thing at? Alright. Over here. I've shown you guys this before, but like in the Linux Systems Administration. Different. Oh yeah. This comes from my golden image talk, right? You guys have seen the golden image talk. People have been around before. So instead of trying to read it there, we'll read it over here because it'll be a little easier to read. But here's some standards. These are just things that I kind of think that you should do. These are things that I do with my home systems. You guys that have been around and seen, like when I build out the, right down here. You guys see the lab here. We can tend to go to any of these if they're up, right? So this dev environment, and for the most part, these are somewhat locked down actually. I think I have, let's see. I have some type of SE Linux running on them, right? They are, you can only come into them with keys, and some of you come in with keys but through the Bastion, right? You come in through the Bastion devices to get over to these, but even then, that is a key. You don't know the key. You have no way to get a hold of that key because you're just in a bash loop before you get kicked over because you're in a jail. But that's all you have there. And then what other things do I have on here? I think we have CD to opt, system, CTL, web system, CTL status, Promtail. I think we have Promtail running on all the nodes. Yeah, so they're sending information up, and we can see what's going on with all of our nodes inside of our Prometheus cluster, right? Sorry, Prometheus, Grafana. We can see them all inside of Grafana. So that's pretty highly available. That's pretty useful. Oh, sorry guys, I'm yawning over here. What's going on over here? Oh, that's what's happening. I was wondering what's going on with my stream stuff. You don't see viewer stuff. Alright. Making sure you guys are with me. For some reason on my YouTube, I've lost my I can see the chat on YouTube, but I can't see like how many people are in chat. I mean, that doesn't matter that much. Doesn't matter that much, guys. I mean, we're just hanging out here. But anyways, these are the kind of things again that you might think about, and if you were to put together maybe like the things that you want your team to automate, it may be deploying these things into your nodes. And you may have some Ansible playbooks that do all default password change across all new Rocky boxes that you open. Or they disable all the accounts that we know of, and we just make sure that those are all, turned off because there's no reason to have them. Then we maybe apply all the benchmarks and make sure that we're at least using like a certain standard of security for encryption and those kind of things. And then, software. Software is a big one, man. Software is this big, bloated. You can at any time on a server. I'm on Rocky 2 right now, right? df-h, how much space he's got? He's got his little temp FS and he's got 6.2 gigs available, right? You can at any time just start installing stuff. I can just say DNF install JDK, right? And I'm pretty sure JDK will find JDK, is that right? Let's look at this one. I think this one will just blow up this machine. No? DNF search all JDK, right? Your Java development kit or whatever. Open JDK like that would have done it. But what if I just, I'll show you guys something real quick. What if I just said, you know what, I want JDK, right? I want this Java Open JDK 1.8.0. Maybe I know that that's the version that I need, or, whatever, right? Hey, how's it going, Less Than T? We're just hanging out. Not working too hard. So let's install it. Even without installing it, let's just drop this on here. Let's just say we want Java in our environment. Who knows why we want Java? That's going to add a lot of additional packages on our system, right? So we'll just go ahead and let that all install. It's just more, Less Than T, thanks for that. You've done a new subscription. That's cool. You don't have to watch any ads for a while. That's kind of cool too. I am sitting in a hotel room in Dayton, Ohio, just kind of relaxing after working all day in a data center and then kind of talking to my college students. So that's where we're at right now. That's what's going on. And we're not working too hard. This is my home lab, right? I told you guys you guys might have thought I was kidding. I can connect to my home lab from anywhere in the world. So I'm in Dayton, Ohio, and this is back in Phoenix in our labs. You guys could be in our lab environment if you're doing the Professional Linux Users Group sysadmin course, right? So it's definitely there. Less Than T, you're prepping to take the HCSA. Nice. One of our guys just passed that in the last couple of weeks, I think. So if you, I don't know if you are still hanging around Discord, but you can always pop in, ask any questions if anybody's got any good study material. So DNF history, and then we can see. Look at this bloat, man. We just installed 135, and our server's just like, ugh. I got all this extra stuff in here, and it's like, if you don't need all this, don't just willy-nilly install stuff, right? This is just, might seem like that goes without saying, but some people are just like, well, I might need the software one day in the future. Look, man, if we don't need it on the server, it's not fucking going on the server. This server is like a drag racer. We want it to perform as fast as possible. We do not need a trailer hitched up to the back in case we need the winch on the trailer. We don't, it doesn't make any sense. Like, I mean, I understand if you're out rock crawling, you need a winch, right? But like, if you literally just drive around in the city with like a 180-pound winch bolted on the front of your vehicle, that is like having an extra person in your car all the time. And that's definitely affecting your gas mileage in some ways, right? And you might say, that's negligible versus what I get. And I say, well, that's fine. That's your risk posture, right? And it's the same thing here. Like, we don't just add a bunch of software. And the software we do have, we have to update and patch it. We have to watch for security vulnerabilities, right? It should only be on. If it's not there, it can't be on. So that's important. But if it is there, it should only be running if it's needed, right? I remember, I think I told you guys a few months ago when there was that CUPS 10 CVE, and I was like, wait a minute, hold on, who's running CUPS? I've never run CUPS professionally across hundreds of thousands of servers. And like, I felt like I was like I didn't understand what was happening. I felt like I was in Bizarro world, because like in the Discord, like every single person I knew was like, I run CUPS, and they were all like standing up like, I am Spartacus, and I'm like, I don't understand what's happening here. You all run CUPS? What the F? Never run CUPS professionally in 20 plus years. But that's just my experience though, right? And I tell you guys all the time, there's all kinds of people having different experiences in the systems world. So anyways, but this is still true. If you weren't running CUPS and you got popped, you deserved it. If you weren't running it, like if it shouldn't have been on in your environment, you guys weren't actively sending printer pages to it, you should have had that shit off, right? It's the same thing with like XINetD. XINetD was a great idea long ago, where it would handle connections in for servers, but it's too variabilized for people to be able to effectively protect it. So XINetD is pretty much gone. I don't think anybody's used that for years, probably since last time I was turning off XINetD for a company was like 2016. That was 9 years ago now, right? So you probably won't run into any XINetD anymore. I don't think so. That's all one word, by the way, too. Yeah, make sure you have good logging. Good logging can mean a lot of things. You don't have to use Loki or syslog, but what I would define as good logging is if your system goes down for any reason, whether it's maintenance or an action of a persistent threat or something takes your system down. Good logging means that you can see what happened to the server before that server comes back up. So what I mean by that is, if your server goes down and we have to turn the server back on, get it back repaired and working for like 9 hours, and then you can see the logs, that's unacceptable. We need to be logging out of systems in real time. That's what Loki and syslog and these kind of things do. Okay. Then we have HIPs, post-intrusion prevention systems. You should turn things on that make it just more difficult for people to slog through your system. Tripwire will show you if things change. Tripwire is not really maintained anymore. A lot of times we're talking about Tripwire-like systems. So you could have Audit D. Audit D is a good one, and you can set up triggers along with Audit D. And by the way, in the STIG standards, they will set up all the Tripwires, or all the Audit D that they think you should have. So at least the basics are set up there. Fail to ban's a great one. Fail to ban is, you can apply that to not just, I use it for SSHD, but you can use it for, somebody posted in the Discord the other day, they were running it for their people connecting into their Nginx. So you could use it for that too. Yeah, there you go. Oh yeah. Well, don't feel bad about imposter syndrome, less than T. Just hang out, right? The Discord's just for hanging out. By the way, guys, if anybody got in late, we are having a talk on Saturday, bringing in a guest speaker. He's going to come talk to you guys. If you need to know when that is in your time, just go up to the top left of Discord. I think if you're on the mobile app, it's on the top right, but it'll show it in your time zone. So different people's time zones are going to be different. Oh, too true. You said the courses were too short for getting your RHCSA cert from your community college. Oh, that sucks. Well, here's the thing. Did you know you could study for it on your own? You guys want to see something cool? I showed this to somebody the other day and they really liked it. So I'll show you guys this. If you're studying for your RHCSA, let me show you guys something. If you guys have never done something like this before, let me posit that this is a valuable thing to do. So you just come up here, and you guys are talking about RHCSA, right? Watch this. I've never done this before in my computer. I've never done this before. RHCSA GitHub. And here are people's lab setups and notes, right? So here's RHCSA. I've never been to this. Look, you guys don't see a different color. I've never been in this guy's page. Not going to be sponsored by him or anything like that, right? I'm just going to this guy's page. And he's got a bunch of his notes, right? There's his passing, his cert or whatever. And he's got one to help you understand the system administration. And you come into any of these things that you feel like you're weak with, like maybe managing containers. And it says that, okay, here's a container. And I'm going to pull up my lab here. And Rocky 2, this guy, by the way, all of the labs in our home lab, by the way, are running Podman, which is basically, you guys know, it's basically Docker. So now he installs Podman. He does Podman search for something. Look, I can just start copying him. Guys, I've never been on this dude's page before. Look at this, Podman search showed me a bunch of stuff. Okay. And then I can pull a very specific one if I want. Right? Never been on this guy's page. This is very similar to one of our labs though, right? I pull that Docker image down, and now I've got this search cache off. What happened? Oh, I didn't delete anything off. I use other browsers for any of that weird stuff. No, I'm just kidding. But now I do Podman images, and now I've got an image. Podman PS still doesn't show that I'm running an image. I downloaded an image. I have one locally. I could do all kinds of things to it and then repackage it up, whether locally or up to if I had like a third party or my own little repository. But I've now pulled that down. Now it says how I can inspect images, and I can go Podman images, which I just did, and I see that I downloaded that. I see when it was created. I see its size. I also see all the layers of it here, right? And now I can inspect from the latest container. So Podman inspect-L will do the most recent container. I'm learning right now, guys. I've never done, oops. I mean, I hope that's a -L. Maybe that's a 1. Should be L. Let's just do Podman inspect and then be verbose about it. So now, yeah, see, I think in ours we just did that, right? So now here's a definition of that, right? And here's information about it, and I could find out all kinds of things about the version of HTTPD involved, and maybe if I know that 2.4. Maybe I know there's a compromise in 2.4.62, or maybe I know that 2.4.62 is past the most recent compromise that my company doesn't have as an acceptable. There's so many things that could be going on here, right? But the point is, we need to know how to use our tools to figure this stuff out, right? So now we need to inspect an image in a remote registry using Scopio. I've never used Scopio in all my career. I've heard of it, but I've never used it. So let's see, DNF install Scopio. Guys, this is why I was telling you to go to somebody's repository. Here's Scopio, install it. And it says I can Scopio inspect this Fedora latest. Never even used this tool, no idea, right? Let's go see what it'll inspect and tell us about that. Oh, look at that. I can inspect something without ever bringing it down onto my system, right? I can see all kinds of information about it. I can see labels that were put to it, right? What's the label information for 41. Kind of cool. We can view logs for container. Well, I don't have any containers running right now, so we'd have to start a container here, which it looks like we could start the container from that library that we downloaded. However, look, this is fun. We would be running this not from our local one, but we would be checking and pulling down a new version of this HTTP. So if this had been re-released in the last few seconds, we would get a new version of it right here. I don't think it will be. But now we do Podman images. We still just have the one. And we do a Podman PS, and we'll see that that pod is running, right? Or that container, as it were. So what I'm showing you guys is like, you can just go to any dude's page. Anybody here, look, this was the third one down. I'll link it to you guys. This is the third one down. Some dude on the internet passes RHCSA, and he, as he did it, he went and wrote up these different things. So we just did a whole bunch of pod stuff in the home lab here. Operate running systems. Do I know how to do any of this stuff? Can I shut down a system? Can I halt a system? Can I reboot a system now? I know how to do all that. Good. Can I shut the system down after 5 minutes? Boom, there we go. Can we boot into different targets? Okay, so this one is a little more theoretical, but we do need to understand how to change the different types of targets, right? So he's explaining it all to you, and he tells you how to mount file systems, which we've done, but now when you're in a system, right, and he shows how to interrupt the boot process, because you always need to know that for Red Hat. That has been like their open secret for like 20 something years. You have to know how to get into the system. It used to be single user mode. Now it's this rd.break, right? And then that'll bring you down in, and then you gotta remount sysroot as read writable because it's read only. And then you can go change the password. And then you gotta do your touch auto relabel. So you can do passwd to change the password, right? That you need to know how to do that. You won't even get in if you don't know how to do that, right? Look, they show you how to do tuned and then how to go and look if you never use this tool. And it's the tunable. It shows what's tunable on the system. By the way, look at all these other things we got to add in. Just more bloat on our servers, right? The True, how you doing? We are hanging out. Not working too hard. I was showing, like, there was some talk about people getting RHCSAs, so I was just showing, you know, people do really good work in their GitHub pages, man. And you come down here, look, there's somebody's study notes, and it said, hey, I passed it. Look at all those stars, so people like it. And it's just a bunch of how they did it. What kind of bash scripting did they have? What are they going to teach me about some bash scripting? Helpful commands, know how to add some value, and if it equals 500, then something else. So that's a dual alternative structure, if then else. Understand. So there's some tests. You can test like this, or you can test with the word test. So he's showing the different ways that you can test. This is the same thing down here. Then they talk about debug mode with -x. Okay, well there you go. So I tell you guys, when I'm getting ready for certs, I look at people's GitHub notes. Because that's what people publish them for. They want you to go look at them, right? So I think there's some really good ones out here, and I think that you can get some good, and then just hop into a box. I'm in a Rocky, I think 9.4, right? I'm in Rocky 9.4, but I bet you I can do 95% of what's in here. What I mean by that is, like, I have the capability over here to do these things. Also, we have SC Linux running, so you can do in here ls-l L capital Z, right? And you can see the additional tagging. So this is an NFS. It's got an NFS label on it, right? Because it's mounted through NFS in our system, right? So, you know, as we look at this stuff, we're just crawling around in Linux systems. That's all we're doing. Not working too hard. Robodom's giving you guys the Discord. He's always popping Discord links up there for you guys. That's a free place for you to hang out. We're trying to get up over 4,000 users. I'd like to see us try to hit, you know, I think we're trying to hit like 5,000 by the end of this year. That'd be a nice little goal. And just, you know, we hang out in there and we talk shop. So that's kind of what we do. Yeah, so where were we at? Let's go look at the group's come a long way. Yeah, Robodom, you've been around since we were under 1,000 for sure. I think you were around since we were under 500. I had to guess. S. Jane Bong. I like the little kitty cat. My wife loves cats. My wife loves cats way too much. All right. So, anyways, here's hardening best practices. This is what we were talking about. And we keep coming down and we say, when do we harden? How do we start to apply hardening to the system? And hold on, I'm going to keep eating my pizza while we talk. I got some pizza earlier from this place. And generally, I don't leave pizza out and then eat it. I want to make an exception for this pizza because it's very good. How do we harden our systems? As we build them, like, so as we plan to deploy the new set of servers, we need to think about how to get this stuff built into the pipeline. Oh, I don't know if I showed you guys this. Hold on. Let me see if I have this still. These were my notes because I know we only had a few people finish the Linux Systems Administration course, and technically there's a little more time left to finish, but I don't suspect we're going to have too many people finish. But this is going to be our next. This is my idea for our next little course. This is what we're going to go to. We're going to do securing Linux. So this will be our next version. It'll be focused on these things. Like we did these things, we touched these things, but we didn't like dig into them. So this is what the next little version of I think our course is going to look like. And obviously you can see I only started etching it out. I haven't finished it yet. Well, I haven't finished any of it, but I got a lot to do. Because we all know how to do all that stuff. I can show you all that stuff. Yeah. So that's the goal of S&T. Get people doing this stuff. Get people confident enough to go work in the space. I mean, it sounds like I'm stuffing pizza in my face. That's what I'm doing, guys. Sitting in a hotel room. Haven't seen the wife since Sunday. So, yeah, less than T. When you go take the test, let me know, or let us know if how you do, all that good stuff. Yeah, Robodom, that's the thing, is the wifey is she's eating pretty healthy back home. So I need to, when I get back home, I'll try to eat a little better too. It's a little harder when I'm on the road, though. All right. So we harden systems as we build them. With change management, while systems are running, we can make changes with proper authorization. We don't want people just changing stuff willy-nilly in an organization. You might say, well, what if they keep the documentation? Even then, there has to be discipline around who makes changes and when. Because, like, for me, it makes perfect sense to just fix the server right now. But somebody else would know that, like, there's going to be a high user workload right now, and any server I touch is going to affect 5,000 users. When normally, if I would just wait till like Friday night, it might at most affect 50 users. And that's a thing that we as engineers need to realize, that we don't always know. We can know everything about the system, but we still don't know how the system is being used. Does that make sense? So the person who technically owns the server is going to be some, manager of a dev team or manager of a security team or whatever. And we can't just go changing their servers willy-nilly. We need to get their permission typically. So that's change management stuff. And, keep them updated with patching cycles and testing. And there is some give and take here. Like, teams aren't going to want to give us their servers. But for security reasons and because of security policies enforced by, like, the CISO, they have to give you the servers, right? So this is a thing. It becomes kind of a contentious area, because people are like, oh, why can't you just patch our stuff? And we're like, well, not if you don't give us permission. We need. And then when you force them, then they don't like that either. So there's a lot of things to think about. All right. So who enforces the standards? These are the teams that you're going to run into as an engineer and administrator. You have security teams. Your systems admins are going to be doing stuff to keep the system running, to keep the system useful for the users. But they can't just punch holes without a reason. They need a reason to punch a hole in something. Like a Kyle, right? He's had monsters, so now he's got a reason to punch holes in things. I'm just kidding. Well, I mean, kind of. Alright. Sorry guys, I'm just stuffing pizza in these still. I got one more slice left and I'm done. This was a large, by the way. But I've been working on it for 4 hours or so. It's not too bad. Make sure I'm not missing anything. Alright. Download shortness and trying to figure out what kind of sysadmin role you're looking for. Am I looking in the wrong places, or pretty standard since your ultimate responsibility to fix things when they go down? Yeah. Unfortunately, let me pull something up here. Unfortunately, a lot of Linux sysadmin work looks like this to start. You kind of, man. I apologize, guys. This is just not a. I don't have a lot of room on this other monitor. Hopefully you guys can see that okay. But a lot of times it's sysadmins. Excuse me. A lot of times sysadmins start over here in the operate and optimize part of the world. So you're working in a NOC or a SOC or a help desk, and it actually happens. Pizza, yeah, pizza was good. All right, we'll wait until the ads are over, guys. We'll give them 45 more seconds and then we'll go. 45 more seconds and then we'll go. All right. That's fine. Down with the shortness. Thank you for the prime. Appreciate that. I don't have any of my sound alerts because I'm not using Streamlabs, but maybe I can add them through OBS. Because I need to get my little Ranger stuff on because I'm on OBS tonight. I stopped using Streamlabs a little bit. Man, that place Marion's, that's some good pizza right there. It's just Marion's. It's good pizza though. Alright. Alright, so down with the shortness. Thank you for the prime. Hopefully you refresh so you don't get ads. What I was starting to tell you though is there's this methodology, it's called the PPDIOO. And it comes from, it's actually a Cisco methodology for how we deploy things. But a lot of times, it's very valuable to look at it from like, this is how sysadmins start, is over here on the left. They operate and optimize systems. That's what they do. You know, things have already been deployed. You come in, you're in the network operations center working the third shift. So like you mentioned, sometimes people really do end up having to put in some hours and some years even. Hopefully when they're younger, hopefully like when you're younger and you don't have a family yet and you're not like traveling too much. But yeah, a lot of times you're operating systems. That's what you're doing, keeping the lights on, running the network operations center and security operations center and help desk. But what I tell people about this is the better you do this, the better, so the more you optimize in your downtime. So in your downtime, you can sit around and read the most recent, Wolverine versus Deadpool in comic form, trying to kill each other. Or you can look for places where documentation hasn't been updated and update that and then send it out to your team. And then just do things that make this better for your team. And eventually somebody's going to go, this guy's doing pretty good at these two things. Maybe we need to bring him in to start as we prepare and plan and design and implement newer technologies. And this is more of like the project work that a lot of people think they want to do. One of those readings will help you go read the documentation and find old stuff in your organization and update it. If you don't have a security policies around and procedures around things, start to make them, right? And so to answer your question, you had asked about if like a lot of this is shift work, and a lot of this can be kind of shitty shift work to start. Some places that you can get into tech and save yourself from like long hours like that is if you can get in with like city or like schools. And I know that because I got into tech through schools. When I first got out of the Army, I was working at a school district and I just moved computers around. After about a year of moving computers around, I was going to school too for, I already had my CCNA, but I was working on my my bachelor's in network communication management. It was a bachelor's of science. And as I was working on that, I was just working at the school district. They moved me up, started working on all the network, started running all the firewalls. I had 2 firewalls that I ran for the whole place, big bastion system, right? And then I also did all the wireless. So I used to do site surveys. So I would show people how to, I show my college students how to do site surveys, right? Like you go out and you figure out, you plan out first and then you go figure out where things really work and how you can put your wireless access points to feed the whole facility, right? So anyways, the point is, that was actually something, I didn't even think about this until later when the wife pointed it out to me, because my wife still works over at that school district. she's never taken work home with her in the last 20 something years of working over there. She's never taken work home ever. And like basically when she's done for the day, she walks out and she doesn't think about work until the next morning. And that's not the case in the engineering world. Like I'm sitting in Dayton, Ohio in a hotel room by myself, right? Because I'm working on a data center. And I thought about that data center stuff all day today, and I'm going to be thinking about it all day tomorrow too, you know? So I actually have some stuff I could do tonight. I'll probably do a little bit, maybe not quite an hour, but I've got some stuff to work on tonight. So yeah, you're gonna find, I don't know, this is one of the things for me is you're gonna find that you probably have to give up a little bit at first. You know, doing this stuff, maybe working the night shift. Help desk is, here's the one thing that's like tragically bad about help desk, and my wife would tell you this too, is you're dealing with people who are very, very frustrated, and they've probably done everything they could before they reached out to you, everything they could think to do. So anything that the help desk tells them, they're probably already mad, right? And you know, like anything that they could possibly bring up, they're probably, you know, already in a different space. Yeah. So anyways, this course that we were working on here, this Linux Systems Administration course, we were focusing on the admin side of things. I was focusing on how to get you guys into administration and how to make you guys better. And it was down here. It was all run out of here for free in the Prolog projects. You can go up there. You can find I will not take any of this down, guys. Like you could go in there like a cartoon villain. I tell you guys, you could join the server. You could take everything you want and put in a sack and run away, and I won't care, right? Like it's there for you guys to use. I think it will help you to figure out what you want to do in the administration side of things, hopefully. Oh, you're in Ohio too. Did you just get hit with that blizzard? I almost died in that blizzard on Monday. I'm not lying about that. Like I was walking around in that blizzard. Anyways, but you're out in Ohio coincidentally doing server backups and RMM work. That's good. Doing a lot of logs and stuff. So I was hoping I could count on something tenure. I see. Company I work for small enough with domain owners really own their stuff and moving behind help desk RMM work. Yeah, that's so. Down with the shortness, I would tell you that is common for people. There's positions above you, but people live and die in them, right? That's probably one of the most common things I've ever heard, right? So, yeah, so I would tell you to, in that instance, you almost always have to move. And moving is made easiest by, you know, really polishing up your resume, showing where you made improvements. Like if when you came on the team, they averaged 80 tickets in the queue and now they only average 20 because you close out 18 tickets a week, put that in there. You know, I dropped the average queue 75% or whatever your percentages are and any of Jero Michi, is that it almost looks like Jeromichi. You said, are there any Linux roles that aren't that demanding? Are there any Linux trolls? That's funny. I said Linux roles. Oh gosh, that's like Always Sunny in Philadelphia. It won't stop saying Linux trolls. All right, well, you guys are trolls now. No, I'm just gonna call you Jeromichi. Asked if there were any roles that weren't demanding. I don't think there's any. Like, the problem with being a Linux engineer, can I tell you guys this? 20 years of engineering now, 20 plus, and 16 years of teaching at the college level. I think that it's 20, not 20, whatever. Like closed captioning is making me a liar. I think that the one thing about, there's a few things. Two, start with one. One, it does not matter how many times you try to show it to somebody else. If somebody else doesn't want to learn Linux or doesn't want to understand it, they're not going to. So you can talk to your manager who loves you because you get stuff done, and you can show them all the things in the world. You will still just be casting Linux spells to them. That's all. They will never know what you do. So that's one. Two, as people find out that you know how to fix things, because I get drug into meetings all the time that have nothing to do with my work, but people know that I know how to troubleshoot things, and people know that I know how to fix things, and because of that, it's one of those things we call it no good deed goes unpunished, because you do good, so now you get drug into other things. And so I don't think there are any Linux related roles that aren't demanding ever. You will always be thinking in Linux, I think. I guess the places I would say that maybe aren't as demanding would be maybe if you were teaching it, because then you're not like probably supporting labs. You know, running your home, like running it at home for fun isn't too demanding, but that doesn't pay so well. So, yeah, the true, you said it demands more the higher you go. Yeah, I mean, definitely the more you do, the more responsibility you have, the more it kind of weighs on you. I do try to tell you guys though, like there are ways as an engineer to keep yourself level. One of the things that I always try to tell you guys is make sure that you're always like kind of honest. Like I'm honest to a fault. Like I'm like that meme. You guys ever seen that little comic where they're like, hey, what's one of your biggest weaknesses? And he's like, oh, my honesty. And they're like, we don't think that's a weakness. And he goes, I don't give a fuck what you think. Right? I know it's kind of vulgar, but the point is, it's true. It's like, I don't care what you think. Well, anyways, where I'm going with that is, I forget where I was going with that, but back to this. Who enforces the standards? Security teams try to, systems administrators do, but a lot of times as engineers, we need to keep stuff on track, right? So this was an administrator course. So I said, why do we care as administrators? Because we're the ones that see the systems and operations. If we're an administrator, a lot of times, the difference between administration and engineering, you guys probably anybody here ever been a mechanic? I've never professionally been a mechanic, but I've done my own oil changes. Have you guys ever heard a mechanic complain about where like oil filters are? They're like, this guy's never changed an engine. They've never changed oil. They've never ever tried to. You're probably right. You're probably 100% right. That engineer probably has never seen his stuff with a broken tie rod. They've probably never seen a slipped axle. They've probably put 100 axles into machines that have been lifted up and it just worked perfectly, but they can't even fathom the kind of stuff you're actually doing to their vehicle. Does that kind of make sense? And where I'm going with that is like the engineers, the guys who build servers and build stuff like the stuff that I do, I don't get beat up by I don't as much anymore get beat up by like people in my company asking me to do stuff like the administrators do. The administrators get asked the most ridiculous shit you guys have ever heard. And I know this because I ran an administration team for a long time, right? I was the tech lead for 5,000 servers at AAA. And we would have people who, they would just want root on everything. We're like, we're not giving you root everywhere. And they're like, well, we want root. That's the request. And they would take it all the way up to like the CISO. And we'd have to bust out we would have to eventually show the policies because here's the thing, right? Because you have to eventually, yes, and I've talked to CISOs many times in my career, being the tech lead of different things, always on the Linux side typically. But I tell people that I would have to tell them, like, look, you need to understand the buck stops at you. Like you are the one who will be criminally liable for breaking this policy, right? And what I mean by that is, I don't know if you guys know how Sarbanes-Oxley works, but it's this law. It's Sarbanes-Oxley. Yeah, it's getting closer. Anyways, if you guys look that up ever, it's basically these two politicians that got together and they made a law after it wasn't the Murdoch scandal, I think it was this other one, but it was Enron, I think. Because what happened in Enron was all the people that were like at the top in the C-level, they were just like, well, we didn't know the people were doing that. Well, they made it so that with Sarbanes-Oxley, like they made it where you can't say that. If you're a publicly traded company and you wear a C next to your name, you are responsible for what I do. And you say, really? And you go, yeah, if you don't have a policy, and then trickling down from that, your managers are making procedures that keep me from doing bullshit, you are criminally liable for stuff that I do. If you don't know that or didn't believe that, it's true. You can go look that up. If you're a publicly traded American company, I gotta give those things. And I'm not trying to give you guys legal advice. I'm just telling you that's true, right? That's what Sarbanes-Oxley does, along with like a billion other things that are also really super annoying. Rama said over on the YouTube side, one of the major things I learned in the job is to have a good understanding about your infra environment. Yeah, you need to be able to. For me, as a Linux guy, I tell you, we gotta understand the environment that we're in. We need to know where things are. In my case, like here's my nodes. If I jump out of this and I go back to my jump box, what's going on in my environment? What's the load levels of my different systems? So these are the systems that run in my environment. I have some Grafana monitoring when I'm at home. I'm not at home, but I have some Grafana monitoring that I can keep track of and see. I could actually get that back to my laptop, but it would just be a hassle to do right now. But we could pull that back, right? And then we could see it. But then, my cluster for people doing all of their labs, we have the little HPC cluster that I was showing you guys earlier that we built up. And I show you guys how Slurm works and all that kind of stuff. And then we got a real production Kubernetes cluster that we can do things in and build things in. And even remotely, we can get to that Prolog site, right? So there's a bunch of stuff here, and then here's the old stuff that doesn't exist anymore. And we can get in through Guacamole. So I've shown you guys the Guacamole connection, right? If I want to connect to some of my systems at home right now, I could go to Guacamole, right? This is my home lab environment. Got to connect to it. I need to put the cert on there. I just haven't done it. And I make a user, and then that's the one I use for here. Yeah, and then if I want to connect into, I think all my red nodes are up. So just connect to my red node. Yep, and there it is. And now I'm in a browser in Dayton, Ohio, connected into my home over a tool called Guacamole, right? And that gives me a shell directly to my box, right in the browser, right? So it's fun little thing to build out. I give you guys, people down in the Discord that want to do lab stuff, I give you guys access to these, right? Super easy to do. All right. Yeah, but this is, this is our Linux stuff. This is what we do around here. Where was I at? I was at this one, and then lab tasks that week. So we did, in week 13, we built an SCC report. Then we hardened some items from the systems, and then I think we rescanned the SCC report to validate changes. And I want to say this week here was the one, yeah, I had just gotten done with my dissertation, so this was one that I think was kind of short and I didn't have as much in there. But if you guys need any questions on that, just let me know. You can ask them up in Discord. Let's go look. That was unit 13, so let's go look at unit 14. We're just kind of reviewing stuff and going over stuff that we've done as a group. So here was unit 14. I think I did this at the same time. I don't remember, but the week before we had done the security stuff, and this week was Ansible. So, we had Michael Pesta come and talk this week. So some of you guys liked his talk. And what did we do? We did automation. What is Ansible? Installing your tools, building your inventory, running your workloads. We talked about the central problem of systems engineering, which is consistency and timeliness. This is a problem that you will always run into building servers. So this is what I call the central problem. And then Ansible fit into systems operations. How do we make Ansible work that way? Because Ansible is just a tool, guys. It sits there inert. It doesn't do anything unless you tell it to. It's not particularly brilliant or anything. It just does the things that it needs to. Hold on, I gotta look at trying to see if there's alright. Yeah, that's fine. Okay. I was looking at, because I'm running OBS today instead of Streamlabs, and I just wanted to see how it works. Robodom, is everything working? Okay. Yeah, Robodom, the thing is, I still have a couple years on my dissertation finishing, but I'm probably going to finish it out with a different college. There were some things that happened at that dissertation that I did not particularly agree with. Oh, it sounds good, Robodom? Okay, good. Yeah, because we're on a totally different platform. We're using OBS. But no, I actually, my final leaving that course was a 99.35% on my 40-page prospectus for my dissertation. So I felt pretty good about that. However, there were some procedures and things that happened during the course that I don't agree with. And I petitioned the school to deal with that, and they told me to go kick rocks. So I said, all right, well, I hope you guys know that I'm paying for this myself. I'm not going, like, I don't have any loans or anything. I'm paying for school as I go. So I was like, well, I guess I could go pay anybody else. So go fuck yourselves. That's pretty much what I told them. So yeah, no, that's the sound of somebody who's a madman. But it's also the sound of somebody, I was thinking about this, like, you know, there's also the sound of somebody who's like not really interested in playing games with people. Like, if you're gonna change the policies and ways that you guys grade things, and after a year of me going to your school, I'm gonna have a problem. Especially when the outcome of that course was a near perfect score on my prospectus, which means that the process worked for me to get me to that, you know. So, anyways, that's frustrating, but we don't need to go into that too much. But suffice all that to say, Robodom, no, I got another little bit until that goes. We do need to get everybody to scale this year. We need to get everybody probably tickets and get everybody that wants to go down there to scale for the. When is that, Robodom? It's in March. Might be time for you to post that again. Yeah, too true. Can I show you something cool? I'll show you the coolest thing. I think this is like one of the best things on the internet right here. I'm going to show you guys one of my favorite things on the internet. I think this is the best free site on the web. It's called Killer Coda. I'll link it to you guys. Well, I'll link it to you guys when I get to... So this guy right here, Scott Champagne, teaches Ansible on here. So we'll go look at his labs real quick. Yeah, I'll head over there. I think, what's that, March? I'll drag the wife out there. That'll be fun. Oh, that'd be awesome. So check this out. This guy, Scott, who goes by Het Tanis, he'll teach you Ansible online for free. Right? This is completely free, guys. Right? Oh yeah, and if that's where Robodom, is that down in Southern California or is that up in Los Angeles area? I always forget where it is, and the reason I say that is because if it's up north a little bit, I'll have Ben go with me too. Pasadena. Pasadena. Oh, okay, yeah, that's right there. I'll get Ben to come with me too. Because Ben lives in over in Anaheim. Isn't Anaheim where Disneyland is? Yeah, that's where Ben is. So if we go up to Pasadena, yeah, we'll get Ben to go too. He's our economist that comes to talk. He's actually, it's funny, he left the teaching gig, so now he's an economist full time with the company, helping him make policy decisions and stuff, making bank, I'm sure, because it was a pay raise, and I know what he was making at the college in California, and that was good. So he's doing real good. So Ben comes and talks to us every now and then about economic policies and stuff. Anyways, let's go back to Ansible real quick. So what is automation? What is Ansible? All of this stuff is rolled up in this guy's, did I link this to you guys yet? Anyways, this guy's Killer Coda course. Oh, I did over there, and did I do it on Twitch? Oh, I did do it on Twitch. Okay, there we go. So he teaches you how to install Ansible. Also, you know, he's me. So He'll show you how to build Ansible. He'll show you how to do a playbook and how to get to all the things that will make your wildest Ansible type dreams come true, right? So install Ansible on the system from the default package repositories. It's going to get you a version of 2.9, right? That's still the version. I mean, it's years later since I wrote these, and that's still the version because it's stable, right? It works well. It is what it is. We get what we get. Hey, how's it going, Ishmael? We're just hanging out and doing some Ansible, Linux, and all that good stuff. What is my? You know what I don't even know? Hold on. Oh, it's not even Sunday anymore. That's funny. I don't even know. I was gonna say I don't even know what the. I have no idea what the Coworking in Linux. That's what it says over there. But on Twitch, it says that on Linux and security topics, it says on a Sunday. Let's get that off. Let's fix that. That's funny. I did not mean to leave that like that. But anyways, we could look at our Ansible version 2.9, 2.96, right? And then if that's true, then we can do things from the version of 2.96. We can go reference things and all that kind of good stuff. So it's one of these things that's nice about if you're gonna do systems work, right? You're going to use an automation tool of some type. You need to know the versions. You need to, in this case, we're going to throw it into the file just so it lets us move forward. And we need to know how to go reference things and how to go look stuff up and how to figure out that there are approximately 3,387 packaged modules with this, right? Then we can go look at one of the modules for setup. We can look at the module for copy. We can actually scroll down over here and see how the copy module is working and what we're trying to do, within this tooling of whatever type, right? There's a whole bunch of stuff that we can kind of look up and figure out and check. And it says, look at you learning Ansible. You saw this challenge. The whole challenge here was nothing. It was install Ansible and do some commands. That was the whole thing. But I think by seeing that, you would be confident to install Ansible in your home lab or install Ansible in a working environment. And think about it, Ansible doesn't do anything unless you tell it to. So it's a pretty inert piece of software to have sitting there. It just kind of lays on the floor like, hey, do something, and then Ansible doesn't do anything, it just lays there. So, what is this? This is like a weird... Guys, I'll add more of our stuff back in on Twitch, or on Twitch and YouTube. I'll add more of the stuff in our OBS now that I got OBS working, and I'll get some of the other stuff kind of going. Oh, that I love emojis. True. I love emojis. I think that's hilarious. Like a little glowing, like a rave. What is this music? This is from one that I bought off a Humble Bundle a while back called EDM Lounge. I don't even know who wrote it, but this is like I have some different, like I don't play some of the other ones, but like I have some other streaming. Here, we'll go to dark. What's dark sound like? Very scary. Very scary in here now. I'm just kidding. All right. What the people want. People want scary. All right, so then you go through and you do these labs, right? And there's I forget how many of these labs there are. There's like 20 of them. But they start you off with Ansible verify that you can install it, build a host file, do some ad hoc commands, like basically like just little one-off stuff in the environment. Ad hoc commands look like this, right? What you guys see me do this ad hoc command all the time, and you're probably like, what the hell is this guy doing? If we go back up. Don't worry about all those pieces of noise. And then this is an ad hoc command. So Control-Shift-R, Ansible. And this is just an ad hoc command. It's not a playbook. It's a one-off. We're calling a shell and giving it uptime. And this would be no different right here. Watch this. This is the way we used to do this. Some of you guys are like, oh, Scott's been around forever. Yeah, I've been around forever. Before Ansible, this is how we would do it. For server in, and then we would do a back tick back in the day. Nowadays, all these youngins do this. They go maybe sec 1 to 19, right? And they close it out like that. That's a perfectly acceptable way to do what I'm about to do. We say do, because now we're entering a loop and we have to have a block of code here between do and done. So we're going to say do SSH to Rocky $ server, and that's going to drop in the server. It's going to interpolate every time it steps through, dropping in the value of the variable of the loop as it counts through each time, right? And all we're going to say is uptime. We're going to say hostname, uptime, and then out here we're going to do done. And this will go hit each of those nodes and tell me almost the exact same information. Now, a couple differences, because I'll show you guys. There are differences to what I'm showing you right here. This will always, 100% of the time, come out. It will either break, or it will be Rocky 1, Rocky 2, Rocky 3, Rocky 4, Rocky 5. What does that mean? That means that these are done in a serial, sequential fashion, right? That's what that means. But if I do this one again, watch this. These nodes are servers right here. We'll go look if we want. Servers are in order. So let's cat Etsy Ansible hosts. They are right here. Rocky 1 to 19. So they are technically in order. But if I do this command right here, and especially if I give like the forks to be 20, this will not come back 1, 2, 3, 4, 5, 6, 7, 8, 19. It will come back in the order that they answered. So these were done in parallel. Look, 12, 17, 5, 6, 9, 16, 3. What if I told you you can't reliably say that it'll be 12 again first? It'll be probably a different one. Watch. What's the top one? Top one. That took way too long. 18, 14, 15, 12, 11. That's way out of order. 1 is down here. 1 was the first one kicked off. On some systems, when they're really fast, you'll get them mostly in order, but they are happening in parallel. That's what the number of forks here, 20, means. I forget what the default number of forks is, so we can grep forks from Etsy Ansible, ansible.cfg, and the default number of forks is 5. But we changed it to 20 there, so now it went all, because otherwise it would have mostly looked, here's the thing, if I had left this off, it would have almost looked, watch, because it would do the first 5, it would have almost looked like they were more in order. You'd been like, well, there's some order there. Not really. There's 1, 2, 3, 4, 5. See how they're all up at the top, and then the next 5 and the next 5? Yeah, true. That one's fun. The wife is a big fan of I don't know if that is a kitty cat, but my wife is a huge fan of kitty cats. She wants to go and see. I have friends who have cats now. 2 different friends that have posted recently on cats, and my wife wants to go see their cats. Not necessarily see them. I mean, she likes them too, but she wants to go see the cats. That's her thing. So, all right. Anyways, ad hoc commands like that, playbooks, and then we just start doing playbooks. It's all playbooks from there out. But the playbooks teach you things, right? They teach you how to do things. They teach you how to move data, pull data, I don't know. I think they're pretty good, but maybe that's just me. All right, so that's that. What else do we have? We didn't go too far into this one. So we did, yeah, that was Ansible. Let's see what we got here. And then I talked a little bit about what Ansible is. This is my write-up from years ago. I just pulled it over to this. And it's just Ansible runs agentless. So most people that compare Ansible to Chef or Puppet, or if you talk about Chef or Puppet or Salt, you're not comparing apples to apples. You're comparing apples to Ansible, because Ansible does not need an agent running to communicate because Ansible is always pushed by default. You go from one local place and then you kick off from there. Ansible. Now, I am a big fan, and I show you guys how to do this in some of those labs, of having Ansible switch around and configure its own node, and then your job is just to kick off the Ansible that runs on each of those environments, right? So I'm a big fan of that because that's proven very effective for me in my career to kind of invert the way that it runs, right? Um, each node doing its own little part to configure itself, as opposed to pushing the configs from one node. So, like a straightforward approach, BGP style. Yeah, fair enough. Fair enough. I'm just a big fan of letting the device configure itself, as opposed to like trying to push from like one node to all of them. So, anyways, so these are some things that I wrote up about Ansible. We talked about it. And then I said install your tools, like install, and then go look at all the different options that Ansible has when you install it. Look at the version, look at the docs. We talked about Ansible using INI or YAML files for your inventory, and then your inventory can include server names, IPs, wildcards, and you can even post variables in your actual inventory. I would advise putting variables in other places unless they're really, really global. But I mean, like, I claim no great expertise in this area. I just kind of do what I've always done, and that's I will put variables in like an environment file if I have one, or and then I showed how to work some little one-off commands, and then how to deploy some tasks and that kind of stuff. So that's what this lab was about. But here's the central problem of systems engineering. You've got the consistency problem, which is repeatability, meaning everything pops out exactly the same. I always think of this as like, if you've ever seen kids squeeze Play-Doh out, and when the Play-Doh comes out, it's all exactly the same. That's what I think of right here. And then timeliness. We don't want server builds to take 2 weeks because you give them to the wrong guy and he just doesn't build the servers, you know. So there's that. How do we attempt to solve that problem? These two problems right here have had a lot of ways to solve them come out of like engineering teams. One is ITIL, that's a big one. Makes us define everything as a service. We treat everything like a restaurant, and we define a menu, but that doesn't actually help us prepare the dishes, though, right? That just tells us how we're getting service to come in and how what our service level agreements are and stuff. ITIL is a great methodology. I'm not bashing on it. I'm just telling you ITIL doesn't solve this problem because it doesn't tell you how to actually make the dishes consistent or make the servers the same. It just helps you define them as, maybe the newer ITIL is different. I haven't done ITIL since version 3, so I think they're up on 4 now, right? But then DevOps methodologies, right? Like attempt to pull the hardware provisioning into like a software lifecycle methodology where everything produces artifacts. Acceptance testing becomes automated. We don't just build servers and then go, they look good. We turn it into like a pipeline, right? And then we always peer review things before they go into production, even if testing was good. We have people come through and check off that, you know, it does have these tools, and then, you know, that's their name on the product as well, not just whoever originally built the process. And if we want to tweak the servers, we just tweak the process, which is super nice. The next set of servers just come out with a different set of software or a new version or whatever. Here's the way that I kind of think of it in systems engineering world, right? Up in dev, we're always spinning. You're always ready to build again. You know, building. So in dev, you're always planning, designing, testing, building, accepting, and then being ready to deploy. And then iteration 2, you're just doing that as rapidly as you need to, right? These can be new servers here. These could be new server builds. This could be Rocky 9.1, Rocky 9.2, Rocky 9.3, and then we've got to have some subversions because I update the kernel. And the prod is always ready. So I may be way up here on Rocky 9.3 in dev. I could have tested this all the way out, and I could be up on Rocky 9.3, and our production servers might still be back on Rocky 9.1. because they are going to be on whatever the most recent stable thing is. And stability and productivity, or stability and security, are always at odds with each other. They're always just going at it with each other. So security is like the enemy of everybody. Productivity, stability, security. Security just wants to push out the new stuff so the problem is solved. The problem of the CVE score, the CVSS is too high. The, the amount of CVSS is too high. That's funny. I need to make a meme of that. Hold on. I'll post in the Discord. Give me a second here. Where's this at here? Meme creator. Cost too high. See if I can find this real quick. Oh, they don't. Oh, there it is. Alright, hold on real quick. I won't post this in the Discord. Yeah, fair enough. I tell people a lot. I don't see any of these things taking the engineering jobs anytime soon, because the engineering jobs, I think, are still pretty safe. Now, some of the ways that we can improve things and minimize errors and that kind of stuff, there's a lot of improvement that I think that like AI and some of this other stuff will help with. Um, yeah, I don't think automation will be taking engineering anytime soon. It still takes. God, there's so many moving parts on some of this stuff. Just so many moving parts on it that it's going to be hard. I'll get in there and mess with that later. I won't post it just yet. And then Ansible fit into systems engineering. This is this comes from a different talk I had, but team writes good code. Code gets committed up to Git, and then we use a tool like Tower or something to run that code and run on a schedule, and then we can test and do all these kind of other things. And then when we're ready, system reports out to the team the results, and then we decide if we're going to push it forward, right? Yeah. Automation is a way to break things faster. Yeah, I'm actually a big fan of automation tooling. Like when I build things, I do want things to break as fast as possible, because I don't want to be waiting around 4 hours to find that a server didn't build right when I was like doing something with it. Like I want it to break in like 2 seconds, so I can look at the error, fix it, go on to the next break. I always think of it like, if any of you guys ever fixed a tire when you were a kid, like you had to patch your tires on your bike, and like you would you'd fill a sink with water, you would fill the tire up, and you would hear the air, but you didn't know where it was coming out, and then you would move it, you would put it under the water, and then you would find where it was, and then you would patch it. What would happen is after that dried, if you went and put that tire back under, you would find like 2 other places that were still losing air, but they just hadn't been losing air bad because that other one was worse, right? So it's this idea that you always go to the next breaking point and fix it. So I do want things to break quickly when I'm building stuff, always. All right. Lab tasks for that week: we installed Ansible, we verified Ansible versions, we generated an inventory. All these things are directly from the Killer Coda labs. And I had them pull a playbook from GitHub and run it. I wanted them to see if they could run it and figure out what it did. Right? And they did. That was a big part of it. Which one was that? Was that 14? Yeah. Okay. The last one's 15. So we've just been reviewing the course. The course was free up on Discord. Anybody that wanted to do it was down here in ProLab Projects. You could go and you can look at pretty much anything going on there. Welcome. Some people joining. Twitch schedule. We have a speaker coming, a guest speaker's coming this weekend, so feel free to watch him if you want. People really like his talks. He does good work. Certification. Good. We passed their Solutions Architect Associate, so that's always nice. We We did a big push a couple years ago. A lot of us were working on AWS. I didn't stick with it because I kind of ended up moving off of that team that was doing that, and there was a lot of conflict, man. Going to AWS doesn't have to be super hard for a company, but if you get the wrong people, I think if you get the wrong people in the engineering roles in charge of it, then you have to look at it and go, what the hell are these guys doing? You know, like what's going on here? And that's kind of what I ran into. Hey, Mr. Robinson, how's it going? We're not working too hard here. We're just kind of hanging out. I'm actually testing out a different way to stream today too, so making sure that it keeps working. I'm making sure that my OBS is doing the things it should. Looks good for now. It's also going to Twitch and YouTube, which is cool. If anybody ever needs help doing that without paying somebody something, let me know, because I found a pretty good little tutorial online and used that. So, yeah, that was good. I think it worked pretty well. Yeah, I think there's always going to be positions for people that are handling automation stuff well. Yeah, Mr. Robinson, congrats. Yeah, let us know. I mean, if you're in the Discord, let us know how the interview goes. I know a lot of people have been looking for work. So, the goal of our group, for people that don't know, is to get you guys doing this stuff professionally. We're trying to get you guys to understand that you can do it. If you're a hobbyist in it, you probably just need a little bit of a push to go work this stuff, but I think most of you can do it. You just need to spend time with it, right? What was this last one? What did we do in the last week? We did inventory ad hoc. That was for the week before. Oh yeah, this one, so week 15, this was the second to last one. We dealt with troubleshooting, and I went really in depth. I actually called this one engineering troubleshooting. So while everything else in this course was actually focused on administration, this one went into engineering troubleshooting as well, because I do think it's important to understand that administrators and engineers troubleshoot things differently. Not because troubleshooting steps are different. Troubleshooting steps should always be the same. The reason I say it's different is that an administrator is simply trying to get the system back up and running, and he's looking at something that could have been working before, should have been working before. You're an administrator. You're sitting at a server or a set of servers, and they should all be on and working. But they're not. And now we have to figure out how to get back on track. There was a track. There was something working at one point. So administrators have that to their advantage. Engineers are sometimes trying to plow a new path that's never been there. They're trying to build a new road into parts unknown. So we have to figure out how to get those things. You know, we are sometimes building things that have not been built before as engineers. Oh yeah, Mr. Robinson, definitely. Oh wow, if you've been around since 486, that's when I started in computing. Although I was not even a teenager yet, but yeah, I started. I think my uncle gave us our first computer in the late 80s, but that wasn't 486. That box wasn't 486. 486 was like in probably our early teens. I think I had an X86, or not even they're called X86, just the 86s, because that was the amount of is that the kilohertz of the systems? I don't know, whatever they were, but they were really low. yeah. I think our Discord's pretty good, Mr. Robinson. I tell people if I had a superpower outside of work, it would be gathering up people around me that are better than me at this stuff. So I tell you guys, go on the Discord and go hang out with other people that are, find people that talk like what you want to talk like. You want to be an engineer and not just you, but I'm saying everybody. You want to find, other people that are doing stuff that you want to do. Go sit where the engineers sit. Go sit where the security guys sit. That's what you want to do, right? Like if you want to be, people that want to go to DEF CON, you gotta go to DEF CON. That's what you gotta do. You gotta go hang with those guys. Yeah, so here's our topics of discussion for this week. And then this one, I remember this one was rather long. We had a lot of troubleshooting concepts. But I started you guys out by mentioning that all troubleshooting comes from the scientific method. And I think it's interesting. I've told people this for a long time. Sometimes in like theoretical physics or economics or whatever, there's a lot of things that are just theory that they've been worked out, they have yet to be proven, or they're just people chewing on concepts and posting them out there for people or whatever. But engineers, we are at this unique place where we are putting science into real practical life. Like if somebody pushes down the gas of a car and that car goes 0 to 60 in 2 seconds, well, those are hard numbers. Those are hard, measurable, quantifiable things. There's nothing abstract about that. It simply did what it needs to, right? And that's kind of like how some of those really fast Teslas are. It's like, well, times are a changing, right? Like the numbers that were like that we thought were really big for a long time, the really good numbers for a long time in like a quarter mile are blown out by like easily blown out right now by like a mom with a bunch of groceries in the back of her car. You guys know that, right? I mean, I don't know if any of you guys know that. Like I grew up, my family like was involved with drag racing. And yeah, like not my family directly, so my son's grandpa on the other side, but we were heavily involved, especially when my son was younger, because my son drag raced for a long time. And it's like the numbers you can put up with a gas car are not even close to the numbers that these new things can do, right? And I'm not saying that like some fanboy. I don't even have an electric car. I'm just telling you it's times are changing. Well, where I'm going with that is the scientific method is something engineers use, and most people probably don't think about that. You're like, oh, you got to be some guy sitting in a lab coat to use scientific method. That's not true. Engineers literally apply science to everyday problems all the time. That's what, in fact, I would almost define engineering as that. That's not exactly how I define engineering, but it's close. All right, anyways, practical tips. Make sure you're documenting everything. Make sure you're getting people involved with the right expertise. Make sure you're using the tools to diagram your thing for visual analysis, because you can tell somebody something a lot quicker with a visual of that thing than you can with like sending an email with a bunch of words. And then you have to be that's what we were talking earlier about failing quickly. Iterative approach means that you can fail quickly and get back to the working thing, and fail the next thing quickly and get back to working again, powering through whatever types of problems you might have run into, right? So these are kind of things to think about as you're doing this, right? As you're thinking about these things. All right. So understanding data. Data comes in continuous and discrete ways. So continuous data would be like your temperature outside. Temperature is not between 0 and 100 degrees of Fahrenheit or Celsius. It could be measured all along a sliding scale of that. And if you wanted to get more and more fine in your tooling, you could get more and more, precise in your measurement of it, right? Whereas like discrete data is like yes or no. Yes or no doesn't really have a continuum. I know people try to say like, truth is subjective, this and this. In engineering, truth is 1 and 0 is not 1, right? Or you can say truth is 1 and anything that's not 1 is not truth, right? That's kind of how engineering looks at it. But in binary, it's either a 1 or a 0. There's no continuum between them. So that's a kind of good way to understand the difference between these. Also, understanding data, it's important that you test and trust your collection tools and methods. It's important that you understand how your tools work, right? If you don't understand how your tools work, you're not going to get good outcomes. You're going to be doing what's called garbage in, garbage out, right? That's not a great look. All right. We got administrative troubleshooting. So how to administrative troubleshoot things. This is a way. Hold on. Voice message. funny. I need to ask the wife. So the wife just sent me a picture of, we were walking the other day and we saw this big snowman outside. You know, people had their decorations up, and I said, "Oh yeah, we should just take it from them. They're probably gonna throw it in bulk trash." And she went out tonight to get some more steps around the neighborhood, and she said it was out in the bulk trash. And I'm gonna tell her, I'm like, "You better not have picked that up. Not have drug that home." God, my wife. All right. I hope she didn't drag that thing home. Like, she just picks it up out of somebody's bulk trash. Oh, my wife. All right. Anyway, so here's 8-dimensional problem solving. There's a bunch of different ways to do problem solving, but this one's okay. I like this. Yeah, that one was pretty good. Right? This is a way to do things. Oh yeah. It's it's big fake snowman. We don't have snow on the ground in Phoenix. I guess it would be better if you guys knew that I'm from Phoenix and there's no. I've seen snow there 3 times and it never stayed on the ground. It just hit the ground. And I remember a couple years ago up north, but still in Phoenix technically. I think it was northern Scottsdale. It snowed and did stay on the ground for like a day. And I remember people like crashing their cars and shit, and we're like, "Why? It's basically rain." Like it did get down on the ground a little bit, but not like on the road. Like the roads were just wet, you know. People were crashing in it. We're like, oh my god, people. Whereas I did deal with snow a little bit when I was in the Army, because Fort Carson, Colorado is in Colorado Springs, and that is quite cold, and they get quite a good amount of snow. Even though they're a high altitude desert, they still get some good snow. All right, so here's some troubleshooting. I like this one. This is one that I learned in the military. I think this is a really good way to figure out the troubleshooting steps. Outcast Wanderer, you did see a picture of people returning Xmas trees to Costco. I saw something like that, and I really hope that was false or fake. We have a 12-foot tree from Costco that my wife bought like in July or August of last year. She argues it was October, and I'm like, I am very positive you didn't wait that long, because it was summer when I drove out there. Because she called me from Costco and was like, I need you to come bring your truck, and I'm like, for what? And she's like, I bought a 12-foot tree, and I'm like, all right, well, she'd wanted it for a while or whatever, but we put it up last year. It was a hassle to get up and down. Put it up this year. It was a hassle to get up and down. So. But we kept it. I mean, we're gonna put it up again next year. It's a really good tree. It's pre-lit and everything. It just does everything we want. But it's Julie likes it because it's 12 feet. It fits right in our window, and you have to see it. Like I live on a T intersection, and people have to drive for like 2 blocks looking at my house. So, hey Harold, how's it going with the raiding party of 7? I am in Ohio right now. I'm from Phoenix, but I'm in Ohio. I'm working at a data center this week on a government project with a couple of 3 supercomputers, and we're just kind of hanging out. So, guys, if you don't know, we follow Harold. We raid over to Harold pretty regularly when we get a chance. Robodom, you mind shouting him out? Mighty Pong, howdy, how's it going? Right now, we're just kind of hanging out, talking about. We did a Linux systems administration course in our Discord, right? And what that looked like was it was just a free course. It's still free. It's up in our Discord. And I just talked about Linux systems administration for 16 weeks. That's what it was. And we ran in Discord. We had like 208 people at one point in there. And we weeded it down to, I think, about maybe 10 people are going to pass and get a little certificate. There's a nice little certificate that we put together. But there's a bunch of stuff in there, and then we had like a lesson that went with each of them. So in this case, we're up in week 15, just reviewing, and I'm talking about the 7 steps of troubleshooting. So yeah. So we're not directly in. I mean, we've been doing some Linux today, like this is a little bit of Ansible. I was showing you guys how Ansible works, but for the most part, we're hanging out over here talking about troubleshooting. Actually, I don't have it in here. Hold on, I do have it in here. This comes from Microsoft. So if you guys don't know, Harold is a what they call a Microsoft what is that called? MVP. Yeah. I have my buddy Chris Turner's an MVP too, and Chris Turner did it all through. He's a cloud architect. He's been a cloud architect for a long time with AWS. So, but this is actually a method that comes from Microsoft. We'll talk about that in a second. But more troubleshooting, guys. You might have seen 876. It doesn't matter as long as you keep your methodology the same. It does matter. Where I'm going with this is don't try to learn, okay, this is 8, this is 7, this is 6. Find one that's good for you. Identify the problem, establish a theory of probable cause, test your theory, establish a plan, fix it, verify the functionality, document your findings, start over if not. This is what you guys kind of do. Oh, it said Snowden instead of Snowman. Oh man. Oh geez, that's funny. Over on YouTube, they're seeing. I guess my closed captioning, guys. I've told you guys. Sometimes I look down and my closed captioning is like not what I'm talking about, and I'm like, what the hell has it been saying? I haven't been looking down there. But anyways, here this comes from Microsoft. I really like this method. It's called React. Easy to remember. Research, engage, adjust, configure, and take note. And research is somebody gives you a problem, you go start finding out about the problem. Then you ask questions about the problem. Maybe you get a meeting together, you ask clarifying questions, you respond, you don't leave tickets. If we're talking admin stuff, you don't leave tickets in your queue. You're always batting tickets back out to the customers or whatever, right? That sounds shitty, but it's accurate because that will gauge to you how important it is to them, by the way, too. So engage. Then you make your changes. Reinstall hardware, reinstall drivers, change settings, figure stuff out. It's already busted, so we got to fix it. Then configure so that the standards are enforced and that you update the standards if they're not being enforced or if they're inadequate for the problem that happened. And then you take note and you make sure that you write it all down. This is a React methodology I actually learned from reading about Microsoft years ago, right? I'm a Linux guy, but I can tip my hat when it's appropriate, right? That's what you should be able to do as an engineer. I'm a big fan of stepping through the OSI model. If you understand what the OSI model is, I was showing this to my college students earlier too. If you understand what the OSI model is, it makes it much easier for you to understand where something breaks. I was showing them this right here. Same thing. If I'm on this server and I can ping google.com, right? Well, there's a few things I don't have to do. If I know that my path out is through this device right here, 192.168.200.1, which happens to be my C router. So my next hop out of this device is through the C router. I don't have to check to see if the C router is on because I know I routed through it. There's these things that I can deduce, right? Like Sherlock Holmes, I can deduce things from what I observe, right? Well, I know that this is the path that it took, and I know that it got out and responded to me, so that's good. I also know that DNS is working on this box because Google is not in my hosts. So if I grep -I Google from Etsy hosts, it's not in there. So the only way my system can figure that out is to resolve it. So if I do like host for www.google.com, I should see 192.178.49.96, 192.178.49.76, and that's where Google is there. Now I can look this up. I can go deeper. I can dig it in www.google.com, and it'll tell me who gave me that answer. Well, 192.168.11.1, which is a home internal router interface that I have off the .200 network, right? Because earlier you saw that I've got this .200 network. This is a different network, but that's where that router responded from to tell my system that was the right IP address, right? But I knew, so I can track where things are busted here by understanding how things flow through the stack. This is how things flow. They flow down on one side, up the other. They only flow as high as they need to for each network device that they go through. That's why I always tell people, like, I'll watch a movie and the crime person will be like, yeah, I tracked them by their MAC address. And I'm like, sitting there shaking my head because the MAC address never leaves the next hop. Never has. MAC address has never been encapsulated and left a next hop. It wouldn't make any sense. It would be like if if you were a UPS driver and you were driving around with my name, and then when you gave somebody like some package, you just handed them my name, and they'd be like, "What the fuck is that? What does this have to do with anything?" And they're like, "I don't know. We thought you'd know." Doesn't make any sense, right? Because MAC addresses in generally are only locally unique. I almost said yokely. They are only locally unique. And what, can I not say yokel? That's funny. I thought that it was blocking me from saying something I wanted to say. My closed captioning will not say all kinds of things. I've tested the limit, right, Robodom? The limit of things that this thing will let me say. But we know all kinds of words that are banned. I wonder if there's a setting. Because I know that we can go in there and look at the... Oh, where is it? It's it's back here. Hold on. Let me see. Can I? Subtitle settings. Can I like... Hold on. I can change all kinds of things with them, but I don't want to. It doesn't look like it's going to let me swear. Alright, fair enough. English, street. Oh. Alright, so anyways, that's how we're getting our closed captioning, in case you guys are wondering. So anyways, back here, walk through the OSI model, know it. The more you know it, the more you'll understand how things break. Then we talked about this one. This one's one of my favorite ones. This is like a doctor right here. A doctor knows systems well, like they know people, and they know the systems within people. Like maybe they're an ear, nose, throat specialist, so they know how those are supposed to look, and they know what is bad and aberrant and all those things. But they don't know you at all. They've never seen you before they look in your ear. You know, they've known you for about 10 seconds typically, but they look for symptoms. Then they identify the most likely cause based on what you told them and what they saw, and then they treat it. And good engineers can do this. A good engineer for like systems, Linux or Windows or networking, can look at what's going on in an environment and go, well, yeah, it might not be this, but this isn't healthy, so let's start trying to fix this. Like the wife always, tells me, go to the doctor, this and this and this. And I'm like, why? The doctor's just going to tell me to lose weight. I already know what they're going to tell me. But anyways, the funny thing is like symptom, identify likely cause, and then treat it, right? These are the things. All right. Then systems thinking is taking that a step further. You need to be an expert in all systems, like this guy. But now you also need to be an expert in this system. You've been around this system for maybe years, and you're one of these people that understands these things well. And we're on our dark stuff. Hold on. Let me go back to our other music. We're gonna go back to our stream and chill. Alright. The music was getting a little weird for me. Alright, let me get some more water out of my fridge. A little fridge in the hotel here. It's right next to me. Right next to my feet. Yeah, that stuff was getting dark. Yeah, that was my streaming dark music. I was like, yeah, that's a bit much. We'll go back to nicer stuff for everybody. I don't mind it too much, but All right, so systems thinking. Look at how all the pieces interconnect. How does data flow? How is it supposed to flow? Like, is it supposed to do this? Like in my home lab here. Let me show you guys something. We come over here and we go to streaming. Monitoring. So this is my monitoring stuff in my home lab, right? Most of you guys have seen this before. This is a 3-stage of how we collect data in my home lab here, right? And the way it all starts, some type of devices are going to try to ingest some amount of data over here on the left. And they might be on any one server, like a telegraph agent, a Promtail agent, a node explorer, right? And then The storage over here is either getting it pushed to it, or in this case Prometheus is scraping it, and then it's holding a bunch of the data here in the middle. And then the data are scraped by Grafana here, and Grafana will pull from each of these different data sources, and we've got our different monitors in our environment, right? So this is like a way to kind of pull and look at information. Well, anyway, so if I look at this one day and Grafana stops showing me things from InfluxDB sources, right? Maybe they're built into some of these other dashboards, so there's a few things integrated, and nothing's showing up here anymore. This actually happened a few months ago because I wasn't paying attention to my storage. This had filled up. Well, so I could look very quickly. It wasn't hard to go figure out that all I had to do was go and look at this component here, because I understood how the system worked, right? Hey, Hack Smarter, how's it going? Thanks for the raid. We are Hack Smarter, not. Yeah, so what we're doing, we're talking about Linux right now, and specifically a Linux systems administration course that we put together. And yeah, Hack Smarter, not harder. I like that. And we were talking through different ways to troubleshoot things, right? This was administrative troubleshooting, and we got down here to stepping through the OSI model, then symptoms, diagnosis, solution, which is like a doctor's method, and then we were in systems thinking, and I was just showing that I can think through how my data is supposed to flow, and then after I see how that data flows, I can make decisions about where things are probably broken. It just gives me a way to like target in quicker where we're looking at for problems in the environment or whatever. That kind of makes sense. So that's our systems thinking. And then there's Kepner-Trago, which is a problem-solving methodology, and they do situation analysis, problem analysis, decision analysis, and then potential problem analysis. So they look at situationally what's the problem? Can we define it clearly? Then they start just laying out questions: what, when, where, how, and they'll start shooting that off to the software engineers and the network guys that are on the call, and the Linux guys and storage guys, and they'll start to figure things out. Then they'll evaluate and choose what's the best solution to stop whatever this is from happening. And then they'll look at potential problem analysis, how to predict future problems from happening, right? Now, oh, that's funny. So that's all administrative troubleshooting. And the one thing that I told you guys that like administrative troubleshooting has as a kind of, I almost want to say as they have it easier, although maybe that's not fair. But administrative troubleshooting, you are looking at systems that were working, and we are trying to get them back to working by bringing them back in line with whatever their original config was. Because theoretically, any broken system that was once working should be able to go back to its manufacturer state and work again, right? Unless something else is like dramatically wrong with it. So then I said that we contrast that with engineering troubleshooting, where engineering troubleshooting is this problem where sometimes we're plowing new areas and we don't know what the actual problems might be, right? We don't know where the solution's gonna lie because there's nobody that's been there before, if that makes sense, all right? This is engineering troubleshooting. And engineering troubleshooting, one of my favorite ones is FMEA. FMEA is an old government system that is designed to identify, assess, and prioritize all risks. Now, anytime we try to predict risks as an engineer, there's a certain amount of our expertise that's going to go into it. And what I mean by that is, how are you going to, like, how would you know to identify all the things that could go wrong with a tank if you had never even like seen a tank or worked on a tank? But maybe you've been building tanks for 20 years and you happen to know that when a tank pivot steers, there is more tension on the outside of the backside tread or track, and you know that that's where the most pressure has, and that's the most likely time you have to throw a track off of the back of that tank. Now, real quick, I gotta emphasize, I was an infantryman, so I dislike tankers greatly, but I'm okay with using them as a bad example. No, I'm just kidding. But anyways, the point is, failure modes and effects analysis, you identify the problems that you think could exist, you evaluate the severity, occurrence, and detection of each failure mode, and then you prioritize them. Is that a big oof, Runamucker? I'm okay with tankers. Come on. It's just tankers are like a sworn enemy of infantry, just like MPs are a sworn enemy of infantry, just like infantry is the sworn enemy of infantry. Like everybody's a sworn enemy of infantry because they, you know. Anyway, so here's more about it. It's a government technique from the 1950s. It's a systematic process to examine what could go wrong, what impact it might have right now and in the future, what's the likelihood of it occurring, and then what's our ability to detect or react. So, we're deploying PRP in a factory network. Yeah. So check this out. I'm going to show you guys here in a second a real FMEA that I did. Yeah, everyone's their sworn enemy. Yes, it's like what was it? Groundskeeper Willie. You've just made an enemy for life. He didn't even do anything. He just was like, you've made an enemy for life because you questioned him, basically, right? So check this out. This is a way to prepare for it. Define systems functions and go through within your systems and define subsystems and where they're assembled and what the individual parts are. And then if you want to look at single parts, this is a way to break things down for FEMA. Or it's not FEMA, but it's FMEA. But I'm going to show you guys an actual one that I did. This is a real one that I did. I'll explain it. Some of you guys that have heard it before, don't stop me, but just listen again. And what the problem was, this is the most salient one. These were the biggest ones. But I did this for, what had happened was we had built, I was working at AAA at the time, and I was the platform engineering lead, and we had built a bunch of servers out. And the way the server, it was a deployment pipeline. And what would happen is any of our 200 or so dev teams could come up, they could push a button in this tool called VRA. There was this VRA, which was basically a catalog, and they could say, I would like a server virtualized, 2 gigs of RAM, or let's say 4 gigs of RAM and 2 CPUs. I want 2 additional 600 gig disks on it, carved up and opt as this, and they could ask for whatever they want it to be. And it's going to be a virtual, it's going to be a non-production machine, and I'm going to need it for 3 months. And they would hit a little button, and we would build a server for them. We would build this whole server from scratch. So what would happen when they hit that button in VRA is there's a tool called VRO, vRealize Orchestrator. That's a VMware tool, and that would kick off. And the first thing it would do is it would go grab an image from some back-end storage to put a golden image that we had onto a deployed, it was like a VMDK that we had and backed up. And they would take it and they would go put it on one of our ESXi hosts in the system. We had hundreds of them, and it would build this brand new system. Well, sometimes that image was unavailable. And how was it unavailable? Well, because maybe the back-end storage was offline to those 10 ESXi hosts, so then when VRO told them to go pull that, they would fail. And our control to fix it was we monitored our vSphere system so that we didn't see that error anymore. We would make sure that error wasn't there, so this was reasonably able to be controlled, right? Then we come down here and automation job kickoffs fail. So you try to kick off, VRO is calling a bunch of different tasks. Sometimes they were my Ansible playbook, sometimes they were other stuff. And the jobs that it would kick off were based on this vRealize Orchestrator system credentials. And they would go out of date because we had a company policy that every 90 days you had to change the password of any service account. Well, that's super annoying, right? So this service account would lose its ability to be credentialed, and it will not work anymore, and we wouldn't be able to build any servers for that day. So the way that we kind of figured to fix that excuse me, is we would do a daily build process. Every morning we would build all the server types that we had. We had let's say 12 archetypes of servers, and we would build all of them every morning. We would get a little report that said they were done. So that was how we fixed that, or that was our control to try to mitigate that, right? Then we had, at the end of things, or as we were registering agents, sometimes the agent credentials would be bad, or they'd be out of date, where there would be like a new webhook, or there would be a new client key or something that we had gotten from like CrowdStrike or something like that. So our agent wasn't able to talk up to their cloud instances and push information. And the way we got around that, and we made sure that that was good, was in our daily build process, we validated that all of our agents were working. So that fixed that, or made that more manageable. And then there was one thing, like sometimes we would get through everything, and at the end the final build check would just fail. We had a little build check that would just make sure everything was good, kick the tires, make sure that the tailgate works on it, all the things were good. And then we just didn't have any way to fix that, so that's going to be a problem. So now this is just, again, this is us looking at what could go wrong. Now we're going to turn this into numbers. So this is qualitative right here. This means hardly anything to anybody, right? Except for me explaining it to you guys, you would probably go, well, that's a cute table, but it doesn't do anything. You're right, it doesn't. This does though. So now we take severity on a scale of 1 to 10, probability on a scale of 1 to 10. Is the music too loud? Am I at least winning? There, I turned the music down a little bit. Is that better? I'm also sitting back. I don't have my good microphone because I'm in Ohio right now. All right, I've turned it down a little bit, and I was sitting back, so I'll sit up a little bit and yell a little more. But look at this real quick. If we have 1 to 10, 1 to 10, and 1 to 10, does anybody know real quick what that math looks like? 1 to 10 in each of these 3 columns here. What is the possible risk priority numbers? The Bossa Nova? Yeah, fair enough. I just want you guys to think. What is 1, 1, 1? 1 times 1 times 1? This isn't one of those math problems where we all make fun of you because you don't remember PEMDAS. It's 1. 1 times 1 times 1 is 1. I don't care where you carve it and if they're parentheses or not, it's 1. And what is 10 times 10 times 10? Doesn't matter what order you do the multiplication, and it's the same answer. It's 1,000, right? So this is a function of triage right here, where we can then go, well, the thing that's going to give us the most headache is this. Mathematically, based on our customer impact, the likelihood of it occurring, and our ability to detect or react from these, right? And I kind of made these numbers up. I think I skewed these numbers just for this discussion. But we can look at this a few ways. Like, this is where we should spend the most time. Or we can look at it like, well, we really need to figure out how to get this detect and react down so that this becomes a more manageable number. And then after that, this is the most insidious one, right? So there's like different ways to look at what the data are trying to tell you here. But the point is, now you have data. Before, you were not even at this. Does that make sense? You didn't even have this. You didn't know what could go wrong. You didn't know what impact. So you went and found out from previous problem techniques. This is not even half of them. I had more. And then this is, I think I skewed these just for the example, because I didn't want to give you guys like the real info, even though it's not that big of a deal. It's just an internal company process, right? Oh, okay, so there's that. Then here's 3 that are really big for engineers. Root cause analysis, like we're sitting around trying to hammer out why something isn't working on a team or between multiple teams. These are 3 that are really good. They're the 5 whys. Ask why 5 times. There's the fishbone, what's called an Ishikawa diagram, right? And then there's an FTA, which is a fault tree analysis. And these are 3 ways to get to the root cause of a problem. There are 3 ways that can help you. I'm not going to be able to tell you here, like, and actually this is one of the major detractions. There's detractors for the 5 whys. They say, well, what if it doesn't get there by the end of the 5th why? And you're like, well, why don't you just say why one more time then? Right? You see what I'm saying? Like, there's no hard, fast rule that it has to be 5 whys, guys. Does that make sense? 5 whys? Oh my god. And then I got kicked off Twitch because my closed captioning said that I was talking about 5 whys. This is how I go, guys. This is how I die right here. Just dying of cringe because of my closed captioning. Alright, I'll be good. Um, so here's the 5 whys worksheet. This is one example that you can find. So what's an abnormal condition? Oh, you know, I drew this up too. When we were talking about this, I drew up an abnormal condition like server logs not going off the server. Well, why did this occur? Well, server logs didn't leave the server because syslog had not started Promtail. Why did this occur? Promtail was on there was a conflicting version between the Promtail and the configuration that was in the server. Why did this occur? Well, because we had updated the version of Promtail inside of our system, but we had not updated the Ansible that deployed the configuration and tested it. So we had an older configuration with a newer version of a tool, and it broke, right? And you could just be writing these down, each of these things, and then you would finally down and then say, why did that happen? Well, because we left a junior guy in charge of it, and he's a shitbag, and he doesn't do his... No, that's not... No, that is actually true. But the point is, as I'm talking about this, like, you sometimes you got to be candid about these. We had the wrong hands in the kitchen, right? There's an old Simpsons episode. This is one of my favorite things to tell my wife because she doesn't like me talking about it. But there's an old Simpsons episode where Homer wants fugu. Anybody remember fugu? What is fugu? It's this Japanese blowfish, and it's like tasty fish, poison fish. Yeah, it's a puffer fish that'll kill you if it's prepared wrong, because if you hit those poison glands, it goes into the meat and you will die eating it, right? Well, anyways, Homer wanted it, and the chef is looking in the book, the junior chef, he's looking in the book to try to cook this stuff, and he touches it with his knife, and the puffer fish just deflates, and he starts moving his knife around going, tasty fish, poison fish. And he like is trying to, well, anyways, I think he gets scared first. Anyways, he goes out back to look for the main chef, and the main chef is in the back of the car with Miss Krabappel, like making out with her and stuff. And he goes, Master, we need your skilled hands. And he looks at the guy and goes, my skilled hands are busy. So the wife will ask me to do shit sometimes, and I'll be like, my skilled hands are busy. Anyways, I don't know why I got on that, but 5 whys. Fishbone, Ishikawa. They tend to use, oh my god, I love that one, dude. It's like, Master, we need your skilled hands. And he just looks at them and goes, my skilled hands are busy. And then that's when the guy almost poisons Homer to death. Fishbone diagram, material measures, measurement, machine, method, environment, and people. You do not have, like, look, I tell people this because I've used this in engineering teams. Like, I've sat there while engineers drew this up on a board and we started tossing stuff at it. If you find out, right, like, if you look at environment, right, and it's obvious, like you have you guys ever seen like those where they have like not cookies, donuts getting dipped, and then they're rolling down the thing, and then they're going through like where they're getting baked, and they're coming out the other side, and you happen to look inside the machine, and you happen to just see a flamethrower going right down on the ones in the middle, and they're just coming out crispy critters, and they're like just pieces of black carbon, right? Well, you don't really have to do all the rest of this fishbone diagram. You could just say, well, the environment is a little too hot, right? This may even be a question of why. Why is the environment too hot? Well, because there's a flamethrower, right? Anyway, so my point in showing you guys out that are talking about that is you can look at these diagrams and then you can start to figure out what is the probable input that is causing the undesirable output of the system. And then that leads you to dial in the input to be within the standards that you want, so that the output comes out in what we call within the tolerances or within the upper and lower control limit if we're doing like a graph, right? So we can draw this stuff out. In fact, one of the things I told you guys as we did this Linux Systems Administration course, I told you guys that I was thinking of doing like just a straight engineering course after and even having some math in it. I think I'm changing paths. I think I'm going to make us do this first. So we're going to do a securing Linux. Whereas we touched on security a little bit in this course, this Linux Systems Administration course, the new course that we're probably going to do is, it'll be a little shorter. but it'll focus on the stuff that we didn't do before, and it'll focus on the security. And then maybe after we do this one, then we'll go back and do like just a straight engineering one. And I think just a straight engineering one would be good for everybody, because if people want to do this and get better at engineering, we can do it. Okay. It's our Discord. We do whatever the heck we want in there. I checked. As long as it's not illegal, like whatever that stuff was that popped up in our webhook yesterday, that was illegal. I think it was sending us some really weird sites. But all right, anyways, that's Fishbone. And then the last one is fault tree analysis, and you use typical logic of and or, fault events, basic events, underdeveloped event, and normal event to determine, like, our plant burned down. Well, there were combustibles everywhere, and a fire was out of control. Well, that's bad. The ignition was smoking or sparks or a short. And probabilities, whenever you discuss probabilities, right? It's interesting to note 3, 6, and 2 here. There's a thing about when we deal, this is obviously not an expansive set, and the reason why is when you talk about the concept of a probability, does anybody know what probabilities always have to add up to? Anybody here do any math? You got to know at least some basic stats to be an engineer. You don't have to be great at them, but you got to know basics. Yeah, well, it's 1. Yeah, it's 100%. It's 1. Yes. You guys are right in what you're saying, but it's 1. Probabilities as a 0.02, 0.06, 0.03. These are not all of the possible outcomes. Now they may be the probability of those outcomes, and then we may say, well, that's 9, that's 11, so that's 0.11. So there may be 0.89 undefined probable outcomes. Does that make sense? But the point is, this is not all possible outcomes, because all possible known outcomes have to add up to 1. They have to. Otherwise, you're not doing probability. You're doing fucking throwing stuff at the wall like spaghetti and hoping it trickles down and teaches you something about engineering or something. I don't know. But you're not doing probability unless it adds up to 1. That's all there is to that, right? At least probability of outcomes. So, all right, fault tree analysis. And then this one comes directly from Edwards Deming, which was the Plan, Do, Check, Act. You'll find this if you go do Six Sigma stuff. So if you guys want to like learn Six Sigma at all, you go to like our beginner start here, and here's all the 6 free certs that I know about on the web, and the Six Sigma white belt is free to take. So if you just want to go get your Six Sigma white belt, in fact, that might be one of our challenges here for the next 2 months while we're waiting. We'll do that. Maybe that would be good for people too. There's other certs that are free for you guys to go get to if you want, like just bolstering the resume. But Plan, Do, Check, Act. And then this has been turned into other things. What is it, like Plan, Do, Check, Adjust? Some people try to say. So there's anything that can be changed, people will change, right? So this is Plan, Do, Check, Act. Again, it comes from Six Sigma typically. And then there's SIPOC diagrams. So that same guy, Edwards Deming, he said a thing that was always interesting to me. He said, if you can't define everything you do as a process, you don't know what you're doing. And I agree with him. Like, if you said, hey, Scott, I'm going to teach you how to do a single leg shot in wrestling. And I go, okay, help me out. Show me how to do a single leg shot. And then you go, okay, well, I do a little of this, and then I do a little bit of that, and smickety smack, and you're on the ground. I'd be like, okay, well, that's a weird way to say it, but okay. And then I say, okay, now can you show it to me slow? And you're like, well, I can't really do it slow. I can only do it fast, right? Well, it's the same idea in systems work and in business. You have to understand your processes, and again, if you can't do it slow, you can't do it fast. So this one's supplier inputs, process outputs, and customers. And then if you look at a process according to that, it'll help you define what's going on as inputs to a process, right? Maybe you're building Vice or something. All right, and then there were no labs because that was the Christmas week or whatever, and then that was that. And then the very last one we did was Unit 16, which I don't even remember what this one was about. So I made you guys do, some of you guys that were there, I don't know if anybody here was there that day, I made you guys actually do some incidents, and we did some fixing of things live. So you guys got to see the pressure of solving problems in the environment. Yeah, he was really big. Edward Deming was big. I mean, the thing about Deming that people loved, and I studied him in my MBA. I don't think I studied him in my information systems management. No, I studied him in my MBA. The main reason he was so popular was this. Well, the efficacy of what he did was shown by rebuilding Japan after World War II. Like, he went over to Japan in World War II after the war was over, and he helped them rebuild and helped them build this industrial powerhouse. So yeah, he was a big TQM. Yep, which is total quality management. Yep. He had his 12 Demingisms and stuff. But one of my favorite quotes of his ever is, "If you can't describe everything you do as a process, you don't know what you're doing." And I think that's true. I think like, if you took all business and economic stuff aside, I think that's true. If you were just like, you do a little of this and you do a little of that and you get a good outcome, I'd be like, well, I don't think I just learned anything there. Listening to you say that, right? It's the same kind of. That's my idea of it. Is he at least was pretty right on that. So okay, incident response lifecycle. So we talked about this a little bit. How we look at policies and procedures. I don't know if I ever heard of his Redbeard experiment. I'll have to look that up. Let me see here. Oh, he did that to teach. Let me see. Several points of 4. Oh yeah, I've never heard of this. I don't know how I missed this. It's right on the website. Oh, I'm gonna have to read up on that. That's pretty good. Yeah, I had never seen that before. I had never seen his Redbeard experiment. I'll look at that. But it is interesting that what I just read there looked like flies in the face of what a lot of people think, because a lot of people do rate people, put them in order, and then expect the same output from them the next year. And it sounds like he directly challenged that. So that seems like an interesting thing. Because I mean, I think, like, especially in the corporate world, because I was in Lockheed Martin for like 5 years, and I've told you guys this before. I thought I did really good at Lockheed Martin. I thought I did very well over there. I was awarded, in my almost 5 years there, I was awarded at least every year. I won at least 3 monetary awards from them for things that I did as an engineer. So over the 5 years I was there, I have 15 awards that were cash paid out to me, right? Now, if you just heard that from somebody, you might think, well, how often do they do that? It wasn't that often, because I didn't know very many people that had anything like that. 1 and 2, there were these things called Tiger teams, where when people could do fixes to things like that FEMA stuff, I was talking, the failure modes and effects analysis. I had been on more of those teams over the time that I was there on this project than anybody else, except for one guy, my buddy Tom Tremblay. And Tom left to go work on GPUs in the early 11-ish, 2012. He left to go work on like early GPU stuff. So he was doing some cool stuff pretty early on. But anyways, where I'm going with that is, I had a manager though that tanked my career over there because he didn't like me, and it was super weird. He gave me the lowest rating he could, and by the rules of the company, he had to give me a PIP, but he wouldn't give me a PIP because he said there was nothing to improve. Yeah, Robodom, it was weird, man. It was super weird. I had this boss who just had it out for me, and I never recovered. I told people, like, there was no way that, like, I didn't stay at Lockheed for a few reasons. They also closed the plant, but the other thing was there was no way to recover from that. You can't go be a fellow and have had a like 10% rating. 10% is the lowest rating they give, meaning you're in the bottom 10% of the company of your people. And I was a level 3 engineer at the time. I was a senior for them, and he gave me the lowest ranking, and I'm like, you can't. It was weird. It was super weird. But weird when you know, have level 5 and 6 engineers that ask you questions daily about stuff. You know, that's the other thing that's weird about it. But you know what can you do? I don't sit around and try to be bitter about it. But the point is, on this, back to this response capability, policies and procedures. I've shown you guys sans.org. You should go there, find policies if your company doesn't have them. Because I always use the example, how can you say that it's wrong for somebody to sit there and watch porn at work? It's, guys, obviously it's not tasteful, but if you don't have a policy against it, an acceptable use policy, AUP, you can't, I mean, man, I mean, I guess people won't like him, but I guess he doesn't care because he's got what he wants to watch, right? And my point is, policies dictate what people do, right? They're a administrative control in a company, and that's a security term, right? Administrative control. You can stop people from doing things. Now, technical controls would be like if you put something in place like a WebSense filter so that they couldn't go to sites that they shouldn't, right? And WebSense was a big one back in the early 2000s. I don't know if they're even still around, but and then they have so policies, procedures, and then the team of who's going to be able to respond. Who do we always call out? Typically, you're going to have who's ever the on-call person first, and then a team. I think that a team should choose when to escalate. Like if you call me out, and I'm pretty sure I can fix it, even though I've never worked on those, specific servers before. But I'm like, yeah, look, I've worked with the guy, I've seen the stuff, I've got the documentation right here. I can give it a try, and I should be able to get it back up in like 10 minutes. But if that team comes back and they're like, no, we need to escalate to whoever now, that's going to cause some problems. That's going to cause some frictions because they don't know what your team is capable of, right? They don't know that maybe I'm the guy who trained the guy that they want me to call out right now, right? And I didn't build those systems, but I had maybe I was the guy who built the original systems and this guy built the new version of them, Like the point is, your team internally should probably do that escalation, not some other team. So anyways, all right, and then there's incident response handling. How do we triage things? We've talked about that a lot. How do we do investigation and containment, and then analysis and tracking? We talked about all that stuff. How do we recover and keep it from happening again? Who do we debrief and how often? And then feedback for maybe external communications. One of the things I tell you guys in the security world, if there's ever a breach of personally identifiable information, right, PII, if that ever gets leaked, the number one rule I tell people is you need to tell your customers before they just find out on the news or something. Because you want to lose customers, like let them find out through some other channel. Don't wait. Get out in front of it. And then mitigation, limit the effect or scope of an incident. If a server has been compromised in a security group inside of AWS, move that server into a different security group, a new security group, in fact, and immediately track logs and figure out what that server is trying to do. But don't let it sit in the same security group with the other devices that it can talk to, eventually compromise as well, especially if they're the same type of servers. That's always a problem. All right. Here's my incident life cycle. This is kind of hard to see, but incident detection and logging, incident classification and prioritization. This is just another way to look at what we saw right here. Initial diagnosis and response, incident investigation, diagnosis. You may wait for later on this. Get your resolution, get your closure, and then you can come back and try to diagnose what the problem is. It depends what type of incident you're dealing with. If you're dealing with a security incident, this might be up front. But if you're dealing with like the server went down because of a power outage, the incident may be recover first and then go look at why later, if that makes sense. That's a thing. All right, and then we had the lab scenarios, and then that was it. So that was the whole thing. That was the whole course. We reviewed it over this last week or so, and all we did was just go in and look at how. What do we do? We just looked at the system. We just looked at everything again, just to kind of review everything, right? Like show you guys that you guys could do it. The official end of that course is on the 19th of this month, so 19th of January. So people that want to try to finish it still and get that cool little certificate, um, which will be the first and only of its kind for that. Um, if we ever decide to do another course or anything like that, it'll be different. So the first one will always be unique. So that's the way we've done that. That's the way we decided that. So, all right. I guess we'll find somebody to raid over on the Twitch side of things. Who's on right now? Who are we following that's up on and online? Running Man's still on. Man, he's been on for a while. Let's go raid Triple Jump Games. We haven't been over there in a while. We'll go raid over to him. If you guys enjoy his stuff, do give him one of our do all the Linux when you get over there. And I definitely appreciate you guys all coming by. I will see some of you later on this week. I'll be traveling on Friday, so maybe on Saturday. All right, and we've got our talk on Saturday. All right, take care.
They're visiting this fantasy world and they asked for a sample of something to take home. And then they trade you something.